Okay, now let's see what is the internet layer and what is the working protocols of the TCP IP stack that we have seen on the previous slides. Internet protocol called IP, as I said, it operates the network layer of the OSI. It's a connectionless protocol. That means it does not require a continuous connection. It just sends the packet. An IP is a hierarchical addressing structure. It aims best effort for the delivery, so that's because it is fast and connectionless. And it doesn't have data recovery feature. That means if the packet down somewhere while in the transmission, it does not recover itself. Okay, what is IP address? We use IP address for the devices we want to get communication with each other in an environment, in a network. And at the same time, all IP addresses must be unique in a network. If all devices has the same IP address, we wouldn't separate them between each other, so all devices has their unique IP address. Okay, and here this is inside of a IP header, an IP packet. You can see this source and their source and destination address. There are also many things in here on an IP header. We will see each of them. As you can see, there are 4 bytes. Each byte includes 8 bits. So in an IP packet, we have total 32 bits. On the first byte, we have version part. It determines whether our IP address is version 4 or version 6. And here is initial header length. It specifies the length of the header. In service type, there is something called QoS. That means the quality of services. Here you can give priority to some packets during the communication. For example, maybe you want some voice and image packets go first, etc. And the packet length section is the sum of header and the packet length. This is only length of the header. This is sum of header and packet length. Identification is the identity of the packet. This info is holding here. And frag offset holds the information of the fragmentation. For example, this is our router. And the packet comes from this side of the router and going that side. So if the packet is very big, it should be fragmented for the value of maximum transmission units. And here is writing which part of the fragmented packet it includes. If the data is fragmented, flag will be marked. And time to live is when you send a ping or when you send a packet, it provides the data is not going to an infinite loop. If the packet couldn't send to the other side, maybe an infinite loop can occur. So when you determine a TTL value, packet has a time to live. And every router, the packet pass, TTL value decreases 1. So packet has a time to live on a network. On the protocol section, we see whether our packet is TCP or UDP. When the other side receives the packet, it will open the headers bottom to top as we discussed before. And first it will open IP addresses on the internet layer. A header checksum is a place that we are checking mistakes. And source and destination address are also here. So, summarize, in an IP packet, we don't only have source and destination address, we also have these parts, as you can see. Okay. And here the format of the IP address used at the page includes some decimal and binary numbers. I hope you know what binary is. Assume our IP address is 172.16 and 128 and 17. And this is binary representation of it. And all IP addresses are actually a straight 32-bit number. We divide it into 4 parts to understand it. It's easier. Each part, in other words, each octet includes 8 bits. And there are IP classes called A, B, and C. And if our first bit starts with 0, that means our IP address is class A. And okay, here is binary representation of an 8-bit octet. And 8-bit is in decimal refers for 128, this is 64, 32, 16, 8, 4, 2, and 1. Sum of them is equal to 255. So you can represent from 0 to 255 with 8 bits. in an octet. Okay, so our class B, it has to start with 1 and 0. The first bit is 1, the second is 0. So all intervals are from 1 to 126, from 128 to 91, and 192 to 223 for class C. As you see here, we understand which class of IP address is with looking the first octet. This is class C IP address, as you can see. And we use subnet masks for dividing network into partitions for use it effectively. All class A, class B, and class C ranges have their default subnet masks. The network and host parse on an IP addresses is actually determined with their default subnets. Due to their default subnets, we define their network and host parts in here. You see network part and host part in class A, class B, and class C. These all are actually determined by their default subnet masks. Okay, class A IP address has a default subnet mask of 255.0.0 and class B and class C here. When you look at class A subnet, you see 255 here. This represents our network part, and the zeros are representing hosts. We will see in more detail in subnetting lessons. And for each zero, these zeros are in decimal. There are actually 8 bits of zeros, each of them representing for hosts. As I said, that means we can use a lot of hosts with class A subnet. That because for each zero we use 255 hosts, and 255 times 255 times 255, we get a number of around 16 million, as you see here. And here is class B. We have two hosts part in class B, as you can see. It's actually calculating with 256 times 256 minus 2, and that equals to 65,534. The reason of minus 2 is we cannot use network IP and broadcast IP in all networks. These are first and last address in a network. So we can't give our clients in a network IP, the first IP, and the broadcast last IP. We can't give them to clients for using. And last is class C. We have only one octet for the host part, as you can see, and the host part is total IP address is 256, and as I said, we can't use first and last IP address. The possible number of hosts for class C, as you see here, is 254. And here you can see this is the first IP address called network address, and the last IP address called broadcast address. Those two IP addresses we cannot attend a client to a network. Public IP address. And there are two kinds of IP addresses we use in a network. One is private, in other words, local IP address, and the other is public IP address. All IP addresses we have seen in the previous slides were all local IP addresses. And the reason they are using public and private IP address, and there are almost billions of devices using internet, and the IP addresses are started running out already. And for example, think about a company with thousands of users. So inside of that network, we use local IP addresses. And when they go to ISP, to Internet Service Provider, the other side of their router, the ISP gives them a public IP address to use. We all are using local IP addresses in our home, in our cell phones, using internet in a network, in a home, and in your TV, with IoT things, with your computer. All devices are in the same network in your home, the inside of the router. We will see in detail working principle of routers, switches later, and for now, it's enough to know for now these things. So Class A public IP addresses, here is range, these class A and these class B and these class C. And as you can see here, class C IP addresses, for example 192.0.0.0 to 192.167.2.255, and here it should start with 192.168 after this, but it is separated for the local IP address you see in the previous slides, and here also it's separated with local IP addresses to public IP address ranges. Okay, and here private IP address range, we have seen this before, and class A, B and C, and these are separated from public IP addresses. DHCP. DHCP means Dynamic Host Configuration Protocol. With the DHCP protocol, clients get their IP addresses from a server, so you don't have to write the IP addresses for each of them. It also assigns default gateways. We will see them later. Okay, and DNS is domain name server or domain name system. The internet system for converting alphabetic names into numeric IP addresses. For example, when a web address URL is typed into your browser, DNS servers return the IP addresses of the web server associated with that name. And DNS providing us to write letters instead of numbers. For example, you write facebook.com into your browser. You're actually requesting your browser to get you the web page of facebook.com. Your browser cannot work with that names, but with the IP addresses. And you are oblivious to the associated IP address. Your computer then checks its local DNS first to see whether it has cached information on this page before. But if not, your browser has never visited this page before. Therefore, your computer performs a DNS requery, DNS request. Okay, we will see them again later with detail. And you can change your IP address in here. And here you can see we talk about subnet masks. We will see default gateway later and the IP address. And here is DNS server. For example, 8.8.8 is globally famous Google DNS server. Okay. And with the IP config, you write your command prompt. You can get the information of your computer's IP address, subnet masks, default gateways, and the DHCP server's IP address, and DNS server also. And here is you can see default gateway is class C. That means our IP address is local IP address, as you see, and this is our network part, and the last one is host part with that subnet mask here, as you understand it easier. Okay. In summary, all IP version 4 addresses have total 32 bits, and this is our local, for example, local IP address, class C IP address. Okay, and here is writing internet hosts require a unique public IP address, but private hosts can have any valid private address that is unique within the private network. So we can say local IP addresses must be unique in that local network, but public IP address the ISP give you, it is unique in all world. That means, for example, my computer's IP address is 192.168.1.11. Maybe in the world there are billions of devices with using the same local IP address, but it means nothing. And you can't use those local IP addresses for public IP addresses. Those local IP addresses are the IP addresses for you can just use in the local. You can't go to the internet with their IP addresses. You should go to your router first. You should go your default gateway first. And when you go to the default gateway, we will see it later. Then you will use network address translation. We will see them in detail in later slides. Okay.